तो सी बेटा, so we will understand the nucleophilic substitution reaction by using our two cats beta. So let's say we have two cats. Let's say we have two cats in these two. See. So what is happening in this? So what is happening? Let's say this cat is a nucleophile, and this is our leaving group. The bigger cat is our leaving group, sleeping, chupchap, Down also see we have a nucleophile and this cat is a leaving group. The cushion on which it is sitting is R, alkyl group. The cushion on which it is sitting, it is R. So these two are the two mechanisms of SN1 and SN2. So down one is SN2 reaction, up one is SN1 reaction. है ना. SN2 reaction में हमने क्या पढ़ा? A nucleophile will come and will attack on the R from backside. देखो, this yellow cat will attack and the leaving group will leave. है ना. In the nucleophilic substitution reaction, we have learned that if I take alkyl halide and if I have any nucleophile will come and will attack on R to make us a transition state, and from this transition state, X will remove and nucleophile will make a bond with R and X will remove as X negative. Alkyl halide will remove as X negative. तो यहाँ पर let's say this nucleophile is X, leaving group is X, RX. This leaving group is RX. देखें RX, है ना. So this nucleophile, this cat will attack on this cushion and will remove the this gray cat and will again sit with R, and this nucleophile will make a bond with the cushion R and nucleophile, and the cat which was sitting the leaving group will leave as X negative, है ना. तो ये वाला तो क्या है? SN2 मैकेनिज्म है कि एक न्यूक्लियोफाइल ने दूसरे न्यूक्लियोफाइल को अटैक करके निकाल दिया, है ना. इन फर्स्ट वन ओनली टुडे वी विल स्टडी द SN1 मैकेनिज्म. इसमें क्या होता है कि अगर हमारे पास एक न्यूक्लियोफाइल है, as soon as before attack only, if nucleophile is just coming here, है ना. जैसे ही न्यूक्लियोफाइल आया, ये ग्रीन वाला कैट पहले ही चला गया, है ना. लीविंग ग्रुप लेफ्ट फर्स्ट ओनली एंड substrate is left alone as carbocations. So nucleophile, before attack of nucleophile only, leaving group leaves and this substrate is made as intermediate. ये एक intermediate बना. Here you have transition state. In SN2 you have transition state, but in SN1 you should have intermediate, and the finally you will have R and nucleophile bond, है ना. So in these two processes, SN1 and SN2, initial condition is same. Both cats are, yellow cat is outside, nucleophile has to attack, यहाँ पर भी, है ना. And final condition is also same. है ना. Final condition में you will make bond of nucleophile and R. Finally, this yellow cat will sleep on the cushion, है ना. So in these two conditions, both the initial and final condition is same. Difference is there how they attack in the mechanism of the reaction. है ना. So ये वाले में you will get a transition state, SN2 direct attack from backside to remove the leaving group, है ना. And this one he says as soon as I come, यहाँ से चले जा भाई, green cat, remove from here, leave my cushion first, then only I will come and sit, है ना। तो ये वाला अगर यहाँ से अटैक होने से बिफोर अटैक ओनली R positive will be formed. ये न्यूक्लियोफाइल this leaving group will leave first, then this nucleophile will come and then she will come and sit, है ना। तो these are two mechanisms of SN1 and SN2, and this is the best example which you have taken to show you कि SN1 and SN2 reaction, in both the reactions, nucleophilic substitution reactions, in both the reaction, you have a alkyl halide, you have a attacking nucleophile, and you are making bond of nucleophile and alkyl halide, and you are removing the leaving group. You are removing the leaving group. है ना। दिस इज द न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन। इसी को न्यूक्लियोफिलिक सब्स्टिट्यूशन कहते हैं कि यू हैव अ सबस्ट्रेट, you have a nucleophile, and nucleophile will attack on the Rx. Now this attack can be two types. This attack can be of two types. It can be through SN1 mechanism or it can be to SN2 mechanism. SN2 may we have studied that it should be a concerted mechanism. It should be a concerted mechanism. It should be a backside attack. It should be a backside attack, and leaving group should leave. Leaving group should leave. It should always have transition state. It should always have transition state. So today we will study what is SN1, है ना। आज हम लोग SN1 पढ़ेंगे, है ना। This SN1 in which we have a cat which will go for पहले से cat चला जाएगा and we will get an intermediate and then R and nucleophile will be making a bond. चलो, so let's study about SN1 देखें। So see, sure. See beta SN, you write one as see as superscript, है ना। ऊपर लिखते थोड़ा सा इसके ऊपर, है ना। SN1 reaction, SN1 reaction, SN1 reaction. So we will study SN1 reaction क्या होता है today, देखिए। So SN1 reaction देखें, let's say I have this substrate. Let's say I have let's say I have this substrate in which I have carbon CH3, and here also let's say I have CH3, and if I have here any chlorine atom and I am attacking on this chlorine atom a nucleophile which is a H2O nucleophile. H2O will act as a nucleophile because it has lone pair of electrons. All those species which are negative charge lone pair species are nucleophiles, है ना। सो इसको अगर अटैक करना तो क्या करता, दिस H2O water is acting as a solvent also बेटा, it is also a solvent. Therefore this SN1 reaction is also known as solvolysis reaction, है ना। सॉल्वोलाइसिस कहते हैं। SN1 का फुल फॉर्म आपको पता है, यूनिमोलिकुलर न्यूक्लियोफिलिक सब्स्टिट्यूशन, यूनिमोलिकुलर न्यूक्लियोफिलिक सब्स्टिट्यूशन, substitution. It is unimolecular, है ना? तो अगर न्यूक्लियोफाइल, व्हाट दिस न्यूक्लियोफाइल, इट इज अ पोलर सॉल्वेंट बेटा. दिस वाटर इज आर पोलर सॉल्वेंट. तो ये पोलर सॉल्वेंट व्हाट इट विल डू, इट विल गो एंड सराउंड द क्लोरीन एटम्स, बिकॉज क्लोरीन इज डेल नेगेटिव and water you have HOH dipole, HOH as dipole, del positive del positive. So it will go and surround the chlorine. जैसे ही that cat goes close to the other cat which is sleeping, है ना, जैसे ही वो गया तो इसने this water will help, this solvent water will help to break the bond of C and Cl, है ना. तो इसने इसका बॉन्ड ब्रेक किया एंड दिस रिएक्शन विल बी आर इन, दिस रिएक्शन विल बी इन इक्विलिब्रियम एंड दिस रिएक्शन इज आर रेट डिटरमाइनिंग स्टेप. इक्विलिब्रियम में है, इक्विलिब्रियम रिएक्शन. तो इसने H2O ने क्लोरीन को सराउंड करके इट हैज मेड व्हाट, इट हैज टेकन क्लोरीन आउट, इट हैज टेकन क्लोरीन माइनस आउट विद वाटर सराउंडिंग्स, है ना. सो इसने दिस कार्बन दे हैड मेड विच विल बी आर कार्बोकैटायन, विच विल बी आर कार्बोकैटायन, है ना. सो वंस वाटर इज एडेड टू दिस alkyl halide, 3-degree alkyl halide, what it will do, it will remove the chlorine first. So this leaving group will be removed first. Leaving group चला गया because of solvent effect, because of solvent effect. अगर ये यहां से चला गया, अगर ये यहां से चला गया, सी, अगर ये यहां से चला गया, so this carbocation is made which is our intermediate, mediate. This carbocation will be our intermediate. देखें, अब ये कार्बोकैटायन यहाँ पर इंटरमीडिएट है एंड इन द रिएक्शन वी हैव वाटर एंड क्लोरीन माइनस. So now again chlorine can't attack on carbocation because it is negative and it is surrounded by water molecules, heavily solvated. So this water molecule lone pair of oxygen will go and now this new nucleophile will go and attack on the carbocation and will make, अब ये वाला यहाँ पर जाके इसके ऊपर अटैक करेगा और अटैक करने के बाद यहाँ पर CH3 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 and will make a bond with carbon. अगर इसने ऑक्सीजन ने अपने इलेक्ट्रॉन्स कार्बन को दिए तो ऑक्सीजन विल बिकम पॉजिटिव चार्ज, ऑक्सीजन विल बिकम पॉजिटिव. नाउ अगेन व्हाट विल हैपन, अगर ऑक्सीजन इज इलेक्ट्रोनेगेटिव इन नेचर, इट कांट टेक पॉजिटिव, सो इट विल डू द प्रोटॉन ट्रांसफर रिएक्शन. It will remove the proton from here and it will transfer proton H positive to another H2O molecule. It will remove H positive from here and it will give H positive to another. This is known as proton transfer reaction. This is also in equilibrium. So यहाँ पर इसने अपना proton transfer कर दिया and it will give us alcohol. It will give us alcohols and it will give the proton to H2O को दिया and it will become H3O positive. H3O positive. Understanding or not? So this is the mechanism of, this is the mechanism of SN1 reaction. SN1 reaction. This is the mechanism of SN1. मतलब SN1 reaction में क्या होता कि any nucleophile is there, if it is attacking on any substrate of X, so what will happen? First, X positive will be made, R positive will be made, and X positive will leave. है ना? So first we have to make carbocation. First we have to make carbocation. This nucleophile will go and try to remove the X from outside, है ना, बाहर से ही निकाला. It does not go and attack on back side in SN1, है ना, इसने बाहर से ही, this nucleophile mostly are solvent in these reactions. Nucleophile mostly are solvent in these reactions, है ना? तो इसने कार्बोकैटायन it has formed, and this is our rate determining step. RDSS, rate determining step. Rate determining step of the reaction. Rate determining मतलब this step is the most important step to do. पहले ये step होगा, then only the reaction further will proceed, है ना? So this is only the main determining step where we have to form carbocation, है ना? और एक once carbocation is made, now nucleophile can go and attack on R, and it can make R and nucleophile bond. It can make R and nucleophile bond, है ना? So see this only. इसको देखें. This is what our SN1 reaction mechanism. This is what our SN1 reaction. Simple. हमने SN1 में देखा कि whenever you have an alkyl halide, you have to remove alkyl halide first. You have to make carbocation. And which carbocation will be made? You should know that carbocation should be more stable. Therefore, 3-degree carbocations, all you know by hyperconjugation, this 3-degree carbocation is more stable. Cl माइनस एक बारी बाहर आ गया, लीविंग ग्रुप निकल गया. तो लीविंग ग्रुप निकलने के बाद this H2O, this nucleophile will go and attack on carbocation and will make OH2 positive, and then after it is proton transfer, which is very simple. तो वहां से H positive निकल के we got alcohols. So write this in your copy. Mechanism of SN1. This is our SN1 reaction. ये SN1 हमारी रिएक्शन है, ये हमारी रिएक्शन है, और ये हमारा मैकेनिज्म है. Here also write that rate see. Here also write that rate of reaction, which I write ROR, rate of the reaction is directly proportional to K times the alkyl halide power 1. Here you don't, so here rate does not depend upon nucleophile. Rate does not depend upon nucleophile beta in this reaction. Rate does not depend upon, so order of this reaction is 1. Order of this reaction is 1. So rate, so here you can write in SN1 reaction, rate of the reaction does not depends upon nucleophile strength, their concentration. It does not depend upon anything, है ना? So nucleophile अगर मैं ज्यादा लूं कम लूं, if I take water less, more solvent, जितना मर्जी ले, the rate of the reaction will be same. Rate depends upon the rate determining step. Rate of the reaction depends upon the rate determining step. तो ये मैं ज्यादा लूं या कम लूं, it does not affect our rate. So the rate determining step is the breaking of the carbon and Cl bond to make carbocations. Once carbocation is made, further step can be done easily. So ये लिख लें. Write this in your copies. I am giving you 2 minutes. Complete and write this in your copy. Good. No, beta, solvolysis can't be done in SN2. For SN2 reaction, you have to take high concentration of nucleophiles, because you need to go and attack करने जाना है. Let's say I am a king and I have to attack on some another empire. So I should have more troops in my क्या कहते हैं, in my war, if I am going for a war, I should have more troops. So my concentration of troops should be more. But in solvolysis, this is not the thing. Let's say I am a king and I have to attack on some another kingdom, है ना? तो मेरे जाने से पहले ही वो वाले लोग छोड़ के भाग गए, है ना? वो पहले ही भाग गए. They have left their kingdom. So I can have less troops also. I can go and simply, what kind of attack I will go to do? Nothing attack it is. I will go and simply occupy their lands and I will enjoy. Understanding or not? Simple example. Today only made. Simple it is. Let's say agar SN1 SN2 reaction. If I am a king, I am going to attack on some another's empire. So for SN2 reaction, if I am going to attack from backside of their homes, for backside attack, I should have more troops so that I can go and fight to remove them from their kingdom. But if I am going by SN1 mechanism, by SN1 mechanism, मेरे आने से पहले ही वो डर के भाग गए. They have left their kingdom. Their kingdom is left with carbocations only. खाली पड़ा है. Their home is left खाली. So I can have less troops. I can have less solvents. Low nucleophiles I can have. है ना? न्यूक्लियोफिलिसिटी भी कम होती मेरे न्यूक्लियोफाइल्स की, तो भी मैं जाके वहां पर अटैक करके आराम से आई कैन हैव माय किंगडम एंड आई कैन एंजॉय माय, आई कैन एक्चुअली एंजॉय माय किंगडम एम्पायर. चलो, डिड यू अंडरस्टैंड बाय दिस simple example? Write yes or no in the chat box. चलो, okay. So let's see the energy profile diagram of this. Same mechanism here also written. Let's see, इसको भी देख लें. Same mechanism here also written. Let's say I have an alkyl halide, है ना? Let's say I have an alkyl halide. We have H2O and I have to make alcohols from this, है ना? So first step, which is the slow step, and it is also the rate determining step to make carbocation. To make carbocation. And you should always have polar solvents. You should always have polar solvent. Polar solvent होंगे तभी इसको यहाँ से इसकी polarity को, they will try to break this bond carbon and chlorine, because this carbon and chlorine bond is a polar bond, है ना? Let's say two brothers and two sisters are there, तो एक को you have to attract one. You have to attract one and take out, है ना? So they have taken chlorine minus and H2O will be sitting with chlorine minus, उसको H2O will engulf with chlorine minus को solvate करके रखता, and you will make carbocation. This is our first step. First step, है ना? Second step is when you have carbocation, then you can attack on carbocation and you can make a product with OH2 positive. This is very fast. This is very fast. Above one was very slow. यहाँ पर water molecule act as a Lewis Bates, donates the lone pair of electron to Lewis acid, carbocation. Carbocation पे attack करता, and once carbocation is made, this is the proton transfer reaction. ये तो proton transfer है. H2O will take the proton and give the electrons to oxygen, and this our product will be made as alcohol. Done. So don't worry, you will get the notes I will give you. So now we will try to write the energy profile diagram of this reaction. Energy profile diagram. Free energy diagrams. Free energy diagram of this. देखें. Let's say पेड़ा बन गया क्या? Let's say this is our free energy diagram, and here I am writing free energy. Free energy is known as Gibbs free energy. आपको पता है डेल्टा जी को कहते हैं free energy, है ना? And here are the reaction coordinates. Coordinates means how fast and slow reaction is proceeding. And it can be temperature, pressure, कुछ भी हो सकता है reaction coordinates. So let's say I am taking reactants which was R. This was our reaction in which I have RX. RX में अगर हम water डालेंगे, so we will get R positive carbocation, R positive carbocation with X minus and H2. Now this will go, this is our rate determining step, slow step, RDS step. This is our fast step in which H2O will attack on the carbocation and will make us ROH2 positive. Now this will go for proton transfer and it will make us the alcohol and we will get H3O positive. देख लें. So firstly, if these are my reactants, these are my products. So let's say I will start from reactants, this energy. Let's say I have Rx plus I will take H2. From going from this to this, I need this much amount of energy. देखें, I need this, let's say this much amount of energy. इतना energy मेरे को चाहिए, है ना? From going uphill to down, you always know the valleys are known as what? Intermediates. So intermediates are, R's will be found here. R positive, which is what? R carbocation. Carbocation is our intermediate. I've told you in the first class also, the valleys are what? The valleys of a energy profile diagrams are intermediates. देख लें. So this, after this carbocation is made, what will happen? After this carbocation is made, we have carbocation, we have X minus H2O. Now this H2O will attack. For this attack also we need little amount of energy because this is a fast step. Fast है तो थोड़ा सा less energy ही चाहिए होता है. अगर यहाँ से गया तो हमारे पास क्या बनेगा? We will make here ROH2 positive. ROH2 positive. And once this is made, we can do the proton transfer reaction. यहाँ पर this reaction is our proton transfer. This हम will show us the proton transfer और यहाँ पर हमारे पास ROH बन जाएगा. ROH बन जाएगा. So in this mechanism, in this reaction mechanism, in this free energy diagram, this shows us that in the starting, if I have this reactants and it is converting to our products, it is converting to our products. It is converting to our products. ROH. It is converting to our products. So the reactants energy, यहाँ से reaction हुआ. This is the activation energy of the SN1 reaction, and this is the only the slow process. एक बारी आप ये माउंटेन पे पहुंच गए, आगे तो फिर आराम से चले जाते, है ना? ऊपर से धक्का भी मार दिया किसी ने तो further you can go very easily, है ना? So यहाँ पर you have to remember that first step is the rate determining step. ये वाले steps, once this carbocation is made, this carbocation पे H2O will go and attack this nucleophile, solvent nucleophile will go and attack to make ROH2 positive. This is also one of an intermediate, oxygen intermediate. और यहाँ पर Again, this reaction will be our proton transfer reaction, and we will get our alcohols as product. Sorry, here I have written reactant, but this I will get as product. So from reactants, I have converted to products, and this free energy diagram will tell us about the energy of reactants and products. Done. So write this in your notes. Write this. I'm giving you 2 minutes. Draw this diagram beautifully in your notes. अच्छे से बनाए. But don't worry, Sohan, I will share you the notes, then you can write it. Leave the space. Leave the space if you have not written, leave the space. Done. Write yes or no in the chat box. Done or not? Sure. Now we will see the stereochemistry of SN2 reaction. देखेंगे हम. Sure. Now we will see the stereochemistry of SN2 reaction. Stereochemistry. Stereochemistry आपको पढ़ाया है. You should know how to see the molecule. Then, so let's say I take this alkyl halide. Let's say I take this alkyl halide. Let's say I have here bromine. Let's say I have here chlorine. है ना? So if I put this in water, water will act as a solvent and also act as a nucleophile. So it will remove the chlorine from here and it will make what? It will try to make for us. क्या निकालेगा ये? यहाँ पर ऐसे बनाएगा. it will try to make here कार्बोकेटाइन, है ना. So let's say यहाँ पर ये कार्बोकेटाइन बनाया इसने ऐसे वाला, and chlorine is left here. So this CH3 which is forward, this CH3 is forward, this is on the plane CH3 and this is CH3. मतलब ये ऐसे it is put on the paper, ऐसे put किया है उसको. This one on the plane, one forward, one backward, one forward, one back, है ना. This is called what? This is the carbocation. ये हमारा क्या है? कार्बोकेटाइन है. See, what are carbocations? These are 6 electron species. These are 6 electron species. These are electron deficient in nature. These are electron deficient in nature. This is trivalent. Trivalent. This is trivalent. है ना. और देखें, it is planar with sp2 hybridized. The hybridization of carbocation is sp2. Therefore, it is planar. You have to remember, carbocations are 6 electron species, electron deficient. Carbocations are 6 electron species, electron deficient. है ना. So see. So this is trivalent. This is trivalent. Trivalent का मतलब it has 3 substituents on 1 carbon. It is planar. You can see a plane. एक plane है on which it is passing. It is sp2 hybridized. This carbon is sp2 hybridized. sp2 hybridized है ये वाला carbon. So this carbocation which is our intermediate. Now we will see the stereochemistry, how H2O will come and attack on this carbocation. How H2O will come and attack on this carbocation. So when chlorine minus goes away, H2O has 2 possibility to attack. Beta. H2 has 2 possibility to attack. It can attack from this side, or it can attack directly from this side. अगर यहाँ से let's say A वाला है और B वाला है, 2 attacks it can do. So let's say we are doing the attack from, let's say I am doing the attack from, let's say I am doing the attack from A side, है ना. अगर A side से मैंने अटैक किया, अगर उधर से आके अटैक किया, so carbon will be made here. ये वाला this side, this CH3 will be made, back side CH3 will be made, and here one CH3, and here you get OH this side. Check. But if I am attacking from this side, OH will come this side, और ये वाले CH3 दोनों उधर साइड आएंगे. अगर मेरा दिस साइड से अटैक हुआ, सो इट हैज 2 पॉसिबिलिटी टू अटैक. इट कैन अटैक, सी दिस इज अ प्लेन, है ना, दिस इज अ प्लेन. H2O कैन अटैक फ्रॉम दिस साइड और H2O कैन अटैक फ्रॉम ऑपोजिट. जिस साइड से Cl निकला है वहां से अटैक कर सकते हैं, या जिस साइड से H2O ऑपोजिट साइड से भी अटैक कर सकते हैं. सो दीज 2 पॉसिबिलिटीज यू कैन गेट हियर. 2 टाइप्स ऑफ थिंग्स, 2 टाइप के अटैक होते हैं, बट दीज 2 आर सेम. But these 2 are same, beta. If you rotate them, they will be same because these are not chiral. Not chiral. Carbon is not chiral. Not chiral compounds. These are not chiral compounds. You can have a plane of symmetry. You can have a center of symmetry. इसको काट सकते हैं हम. I can cut this A and B. If I cut on the plane, I can cut this. So it is not chiral at all. But if I have any carbon on which all the four substituents are different, let's say I have here chlorine, if I have A, B, and C, and if I attack H2O on this, so what will happen? This chlorine will go and carbon will be left with A, B, and C substituents, and this will make a carbocation. Once this will attack, now H2O has the possibility to attack from front side or attack from back side. अगर front side से attack किया, A side से, अगर let's say it is attacking from A side, if it is attacking from A side, so A will be made this, B will be made like this, C will be made this, and OH will be made this side. And if it is attacking from B side, अगर B side से attack किया तो क्या होगा? अगर B side से attack किया तो B side से attack किया तो A वाला इधर आ जाएगा, B1 पीछे चला जाएगा, ये C वाला this side it will come and OH will come this. अगर इधर से अटैक किया तो ये तीनों ABC will shift this side. अगर B से अटैक किया तो ABC will shift opposite side, है ना? तो ये B वाला will shift this side. है ना? So these two are what? These two are what to each other? These two are, अगर इसी साइड से from if it is attacking from same side at it is chlorine, so this is our retention. This is called retention of configuration. मतलब पहले क्लोरीन यहाँ था and again OH came at same place as chlorine. This is called retention of configuration. If OH is attacking from backside, you all know this is known as inversion of configuration. Inversion of configuration. Inversion of configuration. है ना? So अगर हमारे पास OH has to attack from this side or from that side, we can have one inverted product and we can have one retention of the product. So we can have two products. Whenever we have a chiral carbon, on this chiral carbon, if H2O is attacking, it can have two products, A and B. Can have two products, and possibility to attack on A and on B is 50-50%. तो 50% ये बनेगा और 50% ये बनेगा. 50% will be R inversion. मतलब let's say this is R, this will be S, and 50% will be retention, R to R. है ना? ये 50-50% हमारे पास है, दोनों बने हैं, both are there in our solution. This solution will be knowing what? This solution will be known to us as racemic mixture, where we have two compounds, both their optical rotation is opposite, but they have same optical rotation. Alpha they have same. So अगर ये plane polarized light को 10 degree rotate करता, other opposite direction में 10 करता, and both concentration, molar concentration we have same. दोनों का concentration same है, then only we can have racemic mixture in the solution. And this only you have to learn that in SN1 reaction, in SN1 reaction, stereochemistry right here only. I'm writing stereochemistry. In SN1 reaction, what happens? Racemization occurs, and we get what? Racemic mixture of products. We get racemic mixture of products. This you have to remember, है ना? सो SN1 रिएक्शन में आपको कुछ नहीं याद करना है, ये याद करना है कि हमारे पास हमें रेसिमिक मिक्सचर मिलेगा, एंड यू ऑल नो रेसिमिक मिक्सचर इज ऑप्टिकली इनएक्टिव, ऑप्टिकली इनएक्टिव इन नेचर. ये हमने वी हैव लर्नड इन मीजो एंड रेसिमिक मिक्सचर. मीजो एंड रेसिमिक मिक्सचर्स आर ऑलवेज ऑप्टिकली इनएक्टिव, है ना? सो द सॉल्यूशन, the compounds are optically active, but the whole solution will be optically inactive when you have SN1 reaction. ये याद रखें आप लोग. So this is all about what? Stereochemistry of SN1 reaction. याद रखें आप, स्टीरियोकेमिस्ट्री ऑफ SN1 रिएक्शन क्या होती है कि यहाँ पर इफ कार्बोकैटायन इज मेड, H2 has the equal possibility to attack from both the side. Therefore, if we have a chiral carbon, whenever we have a chiral carbon, so H2 will have a equal possibility to attack from front side or back side. अगर वहीं से if it is attacking on the same side on which it is chlorine was gone, it is known as retention. If it is attacking on the opposite side, it is known as inversion. And possibility of attack is 50-50%. Therefore, we get racemic mixture. So this was our stereochemistry. Last thing beta before our class ending only, हम लोग एक और चीज लिख लेते हैं. देखिए, just a minute, give me a minute beta. लास्ट थिंग हम लोग और लिखते हैं. राइट दिस, आई एम गिविंग यू 2 minutes. आप जल्दी कंप्लीट करें इसको. 2 minutes आई विल गिव यू. इसको मैं बड़ा कर देता हूं फॉर यू. यू जूम ऑन योर स्क्रीन एंड राइट. यू कैन जूम ऑन योर स्क्रीन एंड राइट. चल, after completing, write yes or no in the chat box. जल्दी लिख लें. Write yes or no in the chat box after writing. Sure. Written beta, should we shift to next one? Today's class is very important, beta. Last thing, right, beta? Sure. So now you know the mechanism of the reaction, now you know the free energy diagram, and now you know the stereochemistry of it. Now we will see next thing, which is factors factors affecting factors affecting SN1 reaction. Factors affecting SN1 reaction. Factors affecting SN1 reaction will study. देखें which factors are there which will help us to tell at which. देखें. So first factor if I take is what? First factor which is the which will affect the SN1 reaction. Let's say we have Rx. इसके ऊपर हमारा एक, let's say we have any nucleophile which is attacking. We have RDS, which is closed step. We have to make carbocation, and then you have H2O. अगर nucleophile है तो nucleophile को लेते हैं. We have here nucleophile, and last will be our proton transfer, and you have nucleophile. है ना? So first factor which will affect this reaction will be our stability of carbocation beta. Stability of carbocations. Today only I will teach you all the carbocations which was there in your GOC also. है ना? So stability of carbocation is our first factor. इसमें देखें क्या है, इसमें देखें हम क्या. So stability of carbocation में अगर हम if I try to check how to check, है ना? You all know अगर stability of carbocation I am seeing, you should know कि अगर simple alkyl halide है, so in that let's say we have 2 degree alkyl halide, 2 degree alkyl halide, or if I have 3 degree alkyl halide, so in all the 3 degree में 2 degree 1 degree तो रह गया. wait. If I have 1 degree CX, if I have 2 degree alkyl halides, or if I have 3 degree alkyl halide, so always remember 3 degree alkyl halides may, 3 degree alkyl halides are more stable in respect to 1 degree, 2 degree and simple alkyl halide. This is due to hyperconjugation effect, है ना? This is due to hyperconjugation. So let's say if I have CH3X, other if I have 1 degree, है ना? X की जगह let's say X is all, let's say chloro, bromo, chloro, you take chloro here, take chloro here, CH3 chloro, CH2 ये वाला क्लोरो. अगर ये वाला क्लोरो है, देखें 2 डिग्री है, ये वाला कंपाउंड है, और लेट्स से 3 डिग्री, this one, so this is simple CH3Cl है ना, क्लोरोमीथेन. This is 1 degree carbon के ऊपर chlorine is there. This is 2 degree carbon. This is 3 degree carbon. On which carbocation will be made more stable? In that your SN1 reaction will be more favored. So 3 degree carbocations are always more stable. Therefore, this alkyl halide, this Cl, this alkyl halide will be more. This Cl will be more. The rate of the reaction of this Cl will be more. 3 degree वाले का, है ना? ये तो स्टेबिलिटी ऑफ कार्बोकेटाइन आपको पता ही है. एंड लेट्स से वी ऑल नो For stability of carbocation, what you have to see? For stability of carbocation is C directly proportional to plus effect. अगर कोई प्लस में दे रहा है हाइपर कंजुगेशन से, मीजोमरिक से या रेजोनेंस से, अगर कोई कार्बोकटायन को, कार्बोकटायंस आर very less in electrons, if someone is giving, they are stabilizing the carbocation. और अगर कोई उनसे ले रहा है by minus I and minus R, so it is inversely proportional to minus I and minus. This you should remember. So stability of carbocations are always directly proportional to plus I effect, plus M effect, mesomeric plus R, and inversely proportional to minus I and minus R. This you should remember. And stability order also I am writing here only. It will help you to get which one more stable. Stability order I am writing. Stability order of carbocation I am writing. Always remember, whenever you have aromatic compounds, and aromaticity is gained after removing chloride. After removing this chloride, you are making positive and that compound is aromatic. Let's say we take an example on which I have this bromine ring. I have this chlorine. If I remove Cl minus from here, it will be made positive and this whole will be aromatic. 7-membered ring with positives are aromatic. 4n+2 rule. है ना? सेकंड केस, अगर हमारे पास कोई मीजोमरिक है, लेट्स से हमारे पास, लेट्स से this carbon is there and it is attached with oxygen, and here we have Cl. Here if I have Cl, wait, यहाँ पर थोड़ा सा, let's say I have here oxygen and here I have Cl. So this, if I make here carbocation, this carbocation will be stable by the lone pair of oxygen plus M effect, or any lone pair group like NH2, OH, OCH3, any lone pair groups, है ना? This giving plus M effect, they will always stabilize the carbocation. Next one, see, if I have plus R, if I have resonance, अगर मेरे पास यहाँ पर एलाइलिक ग्रुप है, if I remove this Cl minus, here carbocation will be made and this will go in resonance, so this will be more stable, है ना? Always remember, first aromaticity C, then mesomeric C, then resonance C. After resonance you have to see hyperconjugation. In hyperconjugation, you all know you should see 3 degree, then 2 degree, then 1 degree, then simple CH3 carbocation. Then simple CH3 carbocations. Hyperconjugation effect 3 degree are always more stable because alpha hydrogen you need to calculate. Alpha hydrogen यहाँ पर 9 आते हैं, यहाँ पर आपने अल्फा हाइड्रोजन कैलकुलेट किए, यहाँ पर अल्फा हाइड्रोजन 9 आते हैं, यहाँ पर अल्फा हाइड्रोजन 6 आते हैं, यहाँ पर अल्फा हाइड्रोजन यहाँ पर कितने हैं, 3 आते हैं, यहाँ नो अल्फा हाइड्रोजन 0. Therefore, this is shown by hyperconjugation effect, beta. Then after hyperconjugation, you can have inductives. You can see inductive effect. After inductives, you can see minus I, and after minus I, you can see minus R, and last is anti-aromatic. If someone is forming anti-aromatic compound, and now let's say we have this one. कौन सा वाला? Let's say we have 5-membered ring, and on this I have Cl. If Cl is gone, it will make here what? Positive. So अगर एंटी एरोमेटिक है तो it won't go, बेटा. Cl won't go, it won't do. So this is the least stable. Anti-aromatics are least stable carbocations. So this is the order you have to remember. This is the order you have to remember for stability of carbocation. अगर इतना याद कर लेते आप तो आपका जेई एडवांस भी इसी में हो जाता. इसी में है सब कुछ. Everything is there in this stability. So these all plus effects are stabilizing the carbocation. These all plus F are stabilizing the carbocation, and these all minus effects and anti-aromaticity are destabilizing. ये तो भिखारी से ले रहे हैं. They are taking money from the भिखारी, the carbocation which is a भिखारी. Understanding beta? So these are destabilizing the carbocation, and this is only the stability order of carbocation. ये आपको याद करना है. Anywhere you see SN1 में अगर कहीं पर भी होता है तो there should be an aromatic, there should be a mesomeric, there should be resonance, है ना? There should be resonance. Let's say here only if I make benzene, on this I make chlorine here. क्लोरीन है. अगर यहाँ पर पॉजिटिव आ गया, क्लोरीन गॉन हेयर पॉजिटिव मेड, सो बेंजाइलिक एंड एलाइलिक alkyl halides, always remember this only, right? Benzylic and allylic alkyl halides, allylic alkyl halides always undergo SN1 reaction, always undergo SN1 reaction. Let's say I take an example ये वाला. तो इसमें if I put H2O तो क्या करता? So before H2O going, chlorine minus will leave and it will make here carbocation, and this carbocation you all know can go for resonance. यहाँ पर बनेगा carbocation and this carbocation will go for resonance. This side, and now H2O can attack anyway. यहाँ पर करे या यहाँ पर करे, same, both are same. Now H2O can attack and make alcohol, ये वाला allylic alcohol. So always remember benzylic and allylic halides are always undergo SN1 reaction. Benzylic and allylic halides always undergo SN1 reaction. This remember. Because उनके पास एक stabilizing factor है. Because they have one stabilizing factor which is resonance. Similarly, one more example if I draw here. This one, check. This is benzylic. अगर इसके अंदर मैं water डालूंगा, so ये यहाँ पर it will make carbocation on this carbon, and this carbon can go show the resonating structures. This carbon can show the resonating structures अपने like this. ये positive की तरफ जाएगा. Always remember electrons will move towards positive charge. Positive came here. Now how it will go? This will go this side. Now this will be made. Now again this will go. This will come this side. And lastly, this our main carbocation is, because this carbocation is more stable by resonance, resonating structures. And now therefore this carbocation will be made by SN1 reaction. यहाँ पर SN1 होगा. जहां पर भी कार्बोकटाइन स्टेबल होता है वहां पर SN1 रिएक्शन होता है. जहां पर भी पहला ग्रे वाला कैट चला गया अपना छोड़ के, वहां पर SN1 रिएक्शन होता है. रिमेंबर बेटा. नाउ H2O if you attack, it will make here OH2 positive, and you all know it will go for proton transfer, and after proton transfer you will get OH this side. Understanding or not? Simple this is. So our first factor, which is factors affecting SN1 reaction, is stability of carbocation. लिख ले, write fast. Write fast beta. Second factor I am showing you. I'll give you the time to write beta. I will share you the notes. Right. Second factor is leaving group. Second factor is leaving group. You all know leaving group. कौन सा वाला leaving group ज्यादा अच्छा है? देखें. You all know for leaving group RI then RBr, then RCl, then RF. Alkyl fluorides are very poor leaving group, so I minus is best leaving group, then Br minus, then Cl minus, then fluorine minus. This is the leaving group priority. So I minus will leave fast because I minus is bigger in size. जल्दी टूट जाएगा. This bond will be broken fast. अगर यहाँ पर इसको यहाँ पर if they do the solvolysis of this reaction SN1 किया तो I minus will go fast. चल. Next one, third one also, right? Solvent which you have to use, always remember, you have to use in this polar protic solvents. Polar protic solvents. Polar, you know, it should have a dipole moment. Protic means it should have H positive in that. For example, if I take like water is a polar protic solvent. These solvents only will act as nucleophile and they will attack on carbon. They will attack on carbon. Let's say methanol, we have ethanol. C2H5OH, इसको ETOH कहते हैं, ethanol. Methanol, meth, CH3OH, methanol, ethanol. Water, methanol, ethanol, etc. These can be taken as solvolysis. अगर वाटर को यूज करते उसको हम हाइड्रोलिसिस बोलते हैं. दैट रिएक्शन इज नोन एज हाइड्रोलिसिस. इफ मिथेनॉल इज यूज इट इज नोन एज मिथेनोलिसिस. मिथेनोलिसिस है ना. मीथेन को यूज करते हैं तो इसको मिथेनोलाइसिस कहते हैं. मिथेनोलाइसिस, मिथेनोलाइसिस है ना. अगर ETOH को यूज करेंगे तो इसको इथेनोलाइसिस कहेंगे. इथेनोलाइसिस कहेंगे है ना. वाटर का यूज करके रिएक्शन करते हैं. यू ऑल नो इट इज नोन एज हाइड्रोलिसिस. विद वाटर रिएक्शन with methane it is known as methanolysis. Simple it is. Done. Fourth one I am writing effect of nucleophiles. Effect of nucleophile देखते. There is no effect. There is no effect of concentration and strength of nucleophile. इसको तो कोई भी चलेगा भाई. वंस में कोई कुछ भी आया, ये तो सॉल्वेंट भी, ही कैन यूज सॉल्वेंट ऑल्सो, इसको कुछ भी चलेगा है ना. सो देर इज नो इफेक्ट ऑफ कंसंट्रेशन एंड स्ट्रेंथ. द रेट ऑफ द रिएक्शन डिटरमाइंड इज डायरेक्टली प्रोपोर्शनल टू एल्काइल हैलाइड्स and is independent of concentration of nucleophiles. So rate does not depend upon concentration of nucleophiles. Rate depends upon only on the concentration of alkyl. ये याद रखना है आपको कि SN1 रिएक्शन में न्यूक्लियोफाइल्स डिपेंडेंट नहीं हो. चलो. So these four are our factors which are affecting SN1 reaction. First factor was stability of carbocation. Second factor is the leaving group, which leaving group will leave fast. Third factor that we should have a polar protic solvent. Fourth factor is nucleophile. There is no effect of nucleophile on the SN1 reaction. समझ रहे कि नहीं? समझ रहे हैं आप कि नहीं? अगर आप समझ रहे हैं so write this in your notes, beta. Complete your notes. So lastly, last thing I'm giving you, today's last thing is, let's see, difference between SN1 and SN2 we will see. अब एक लास्ट थिंग सी इसमें एक और देखें. For SN1 reaction, main thing we should have substrate that can form stable carbocation. है ना? SN1 reaction में our main thing it should have a stable carbocation. Substrate with leaving group at tertiary position 3 degree में सबसे ज़्यादा होता है. You should know 3 degree में always SN1 reaction होता है. Nucleophiles can be relatively weak also. है ना? You can have weak nucleophiles also for SN1 reaction. Solvent should be polar protic solvents. And a solvent should be polar protic. Therefore, ETOH, MEOH or water as solvent. SN1 mechanism is important in solvolysis reaction. है ना? हमने बताया SN1 is also solvolysis reaction. And in solvolysis, nucleophile is weak, therefore it is a neutral molecule. Mostly nucleophiles which are used are all mostly neutral molecules of polar protic solvent rather than anion, है ना? तो अगर let's say I have OH minus and H2O, I can use OH minus in SN2 reaction, but I can also use H2O which is a new weak nucleophile than OH minus for my SN1 reaction. है ना? So अगर मेरे को OH minus पे अटैक करना है and H2O we have two possibility. So OH minus को मैं SN2 में यूज करूंगा, H2O को मैं SN1 में यूज करूंगा because H2O is weak. है ना? लोन पेयर ऑलवेज रिमेंबर इलेक्ट्रॉन डेंसिटी में हमेशा याद रखना that lone pairs have more electron, this negative charge will have more electron density than positive charge. Negative charge, this negative charge will have no more electron density than lone pair of oxygen. है ना? So they can donate more. They are more strong nucleophiles. OH minus are more strong nucleophiles than S. So last thing we am telling you, SN1 and SN2 reaction ka difference we will write. What is the difference between SN1 and SN2? And with this, our class for today will be over. See? See? If I am talking about SN2 reaction and if I talk about SN1 reaction, we will try to compare these two reactions based upon what we studied. See beta, in SN2 reaction, we have one step concerted mechanism. Concerted mechanism. You all know it is a one step concerted mechanism. है ना? Or SN1 reaction is two steps. First carbocation is made, then it goes for proton transfer attack. It is a two-step mechanism with formation of carbocation. Let's say we have RX और यहाँ पर हमारे पास न्यूक्लियोफाइल है, इसको बैक साइड अटैक करके we will get our transition state R nucleophile X, which is our transition state, and it will go further for nucleophile and R, and X will be removed as leaving group. But this one SN1 mechanism में क्या होता है कि before nucleophile only RX में this X will remove and it will make what? Carbocations. One carbocations are made, carbocation make हो गया, then this will go further for attack of nucleophile to give you R and nucleophile with X minus. In water, you have proton transfer, other step also, one step more it can. है ना? So, second thing, if I write for SN2 reaction, these are, you know, order of SN2 reaction is 2. So, they are bimolecular in nature. So, in the rate determining step, you have two molecules which are combining and for giving you the transition state. But order of this reaction SN1 is 1. In the rate determining step, which is slow step, is dependent upon Rx only. So this is unimolecular. Unimolecular, it depends upon Rx only, does not depend upon nucleophile. है ना? ये आप लिख लें अच्छे से. रेट इज इक्वल्स टू आर एक्स इंटू न्यूक्लियोफाइलिक स्ट्रेंथ. Here rate is equals to k times only the Rx. Only the Rx. Third thing, right, beta? Here you have to see what in SN2 reaction you have to see the steric hindrances. You have to see steric hindrances and you form what transition states are formed. Transition states is formed. But in SN1 reaction, you don't have to see steric hindrance. It depends upon what? It depends upon carbocation stability. You have to see only the carbocation, which carbocation is more stable, that only you have to see. Then in stereo, if we will see in stereo, in SN2 reaction we have learned we will get inversion. But for stereo of SN1, we have learned today only we will give you racemization. It will give you racemic product, optically inactive product, racemic product. याद रखें, this is very important bit. Nucleophiles here, if you have to use, they should be, the concentration and strength should be strong. Good nucleophiles and strong nucleophiles. Strong and good nucleophiles, their concentration should be strong, good strength, and their strength also should be strong. So good nucleophiles यहाँ पर use करते. But in SN1 reaction does not depends upon concentration of nucleophiles. Concentration of nucleophile के ऊपर नहीं depend कर. No role of nucleophile. Always remember. Sixth part, see, always remember that in SN2, if we have Cx, then you should have 1 degree because it is steric hindrance. आपको steric hindrance देखना है. ये this, write this point under this only. इसके अंदर ही लिख लें. Steric hindrance you have to see. Let's say we have CH3x or we have 1 degree. Alkyl halide 2 degree. है ना? 2 degree Cx, or if I have 3 degree Cx. So 3 degree Cx में, wait, in the opposite I have written. In 3 degree Cx, let's say we have this alkyl halide 1 degree Cx, 2 degree Cx and 3 degree Cx. So you have to see the steric hindrance. इसमें सबसे 3 degree में सबसे ज़्यादा steric hindrance, therefore it will be very less reactive. But in carbocation you always know कि किस में सबसे ज़्यादा होगा, 1 degree में और 2 degree में और 3 degree में. Out of all 3 degree will be more 1 degree than 2 degree. So always remember beta, in SN2 reaction, whenever you will see SN2 reaction, you always try to use in 1 degree and CH3. 3 degree में नहीं होता. You can't do 3 degree में SN2 reaction because it is more steric hindrance. Understanding? Or if you have SN1 reaction, always in 3 degree use, 1 degree में ना करें. Never use in 1 degree SN1 in CH3X SN1 नहीं कराएं. Always in 3 degree you will use SN1 mechanism. In 2 degree always in 2 degree check the solvent. In 2 degree always check the solvent. And with this, our last thing for today's class, Last thing है क्या? Last thing, solvent which you have to use in SN2 is polar aprotic solvent. Polar aprotic solvent example I am taking DMF, DMSO, dimethyl sulfoxide and THF. But if I am talking here, solvents, if you have to take, which will facilitate this reaction will be polar protic solvents. Polar protic solvents example, let's say we have water, we have methanol, we have ethanol. So understanding SN1, SN2 reaction, today's last class of SN1, SN2 reaction, understand क्या होता है कि SN1 और SN2 में SN1 or SN2 में difference is there. The difference is it is a one-step, SN2 is a one-step concerted mechanism, but SN1 is a two-step mechanism. SN2 is order 2, SN1 is order 1. Rate depends upon in SN2 on Rx and nucleophile both, but in SN1 it depends upon Rx only, nucleophile is not dependent. In SN2, you have steric hindrance transition state, but in SN1, you have carbocation stability. You have to see carbocation stability. In between, you will form carbocation intermediate. You have carbocation intermediate. You have. Next, you have stereochemistry. If I check in SN2, you will get inversion. In SN2, you will get inversion. But in SN1, you will get racemization. In SN1, you will get racemization. Nucleophile concentration and strength should be good. In SN2, it should be a strong nucleophile and it should have more strength, more concentration of nucleophile. But in SN1, it does not depend upon the concentration of nucleophile. Last, we have solvent. If we have polar aprotic solvent, we will go through SN2 reaction. If we have polar protic solvent, they will facilitate SN1 reaction. And with this, our chapter of SN1 and SN2 is over. है ना? बहुत simple है. It's very simple. Just go through the notes. अच्छे से prepare करें. And then check in the questions. In the questions, which question is showing you SN1 and which question is showing you SN2. So one question we will do today only. Don't worry about this. I will give you the notes, then you can complete. I'm giving you 2 minutes. Draw this table in your copy. जल्दी से ये अच्छा सा table draw कर ले. So it will be helpful for you. Draw this comparison in exam. If it comes, differentiate between SN1 SN2 reaction. These 6 points, if you write, it will be more straightforward and direct. Sure. नो बेटा, वी कांट यूज HCl as solvent in SN1. नहीं कर सकते. HCl से कैसे निकालेंगे बेटा? HCl can't be used. It's an acid. HCl is an acid. Correct. Right? 2 minutes I am giving you. Then we will start our doubt session and others will solve. Those who have doubt, they can raise their hands and they can ask, and others can solve the question. 2 minutes I am giving you more.